Hello everyone, in today's video we are looking at 2024 paper 1 and we'll be answering question 22 to 23. Okay, and the question is a straight line which is L is perpendicular to this equation here, which is y equals 3x plus 4. L passes through the point which is 3 comma A, has a y-intercept, find value of A. And for 22b, the diagram shows a sketch of the graph of a curve path through this point, which is negative 5, 0 and negative 1, 0. Here y it is 0, only x has got the values. So without wasting much of the time, let's get started for solution. We have to get this information which we have. We have y equals 3x plus 4, and we have let me use another marker. We have this point which is 3 comma A, and there is 3 as the y-intercept. 3 is the y-intercept. So now we have to find the value of A. That's what we are focused for. So first of all, for you to find the value of A, what you should do, you must find the gradient from this given equation, which is a line. Okay, so the gradient which is at this equation, it is this 3 from that formula, which is y equals mx plus c. So where there is m, you have 3, and where the c we have 4. Okay, so now since we're only focusing on finding the value of A, so now let's find the gradient at perpendicular. This is the normal gradient. M1 it is equals to 3. This is the normal gradient. So let's find the perpendicular gradient. Perpendicular gradient is given by M1 times M2 should be equals to minus 1. In M1 it is 3 times M2 equals to minus 1. Then 3 times M2, we are going to have 3M2 should be equals to minus 1. And divide throughout by 3. So the gradient at perpendicular gradient, it is equals to minus 1 over 3. Okay, since we have found the gradient at perpendicular, so now let's try to create a space. Since we have found the gradient at perpendicular as a so gradient at perpendicular gradient is equals to minus 1 over 3. Okay, so now we are going to use this equation. There is this equation which has got a y equals to mx plus c. From this coordinate which have been given, we have x1 and the y1. Okay, in which here we have y equals to gradient, it is minus 1 over 3x plus c. We are told that it is equals to 3. So where this 3 you substitute with it, because 3 it is y-intercept. This is 3 y-intercept. So this is 3 here, in which it will be y, because you have 3 here and 3 here, so we are going to have x times 1 here, you are going to have minus x plus 3 over 3. Okay, so this is the one over equation. So let's find another equation using the same point here. Okay, so in which we're going to say y minus y1 should be equals to m open bracket x minus x1 close bracket. Okay, in which y minus y1 we have a, which should be equals to gradient, it is minus 1 over 3, then open bracket x minus x1 we have 3. Okay, in which 3 times y we are going to have 3y minus 3 times a, which is minus 3a, which should be equals to, here we have remained with minus 1 times x, you're going to have minus x, minus 1 times minus 3, you're going to have positive 3. Okay, so now if you reach here, you can substitute where this y with this equation, because we're only focusing on finding the value of a. Okay, we're only focusing finding the value of a. So in which we are going to substitute 3 open bracket then minus x plus 3 over 3 then close bracket. Okay, then minus 3a, which is equals to minus x plus 3. Okay, I hope you are following what I'm doing here, in which this 3 and this 3 goes. Okay, in which here we will remain with minus x plus 3 and minus 3a equals to minus x plus 3. Here you have minus x and minus x, it is common, so this x and this x cancels. If you want, you can do minus x when this minus x approaches the cosine to be positive x. So minus x plus x, you're going to have 0. So here we have remained with when this 3 approaches the cosine to be minus 3, so it will be minus 3a equals to 3 minus 3, in which it will be equals to minus 3a equals to 0 when you divide throughout by minus 3, in which a, it will be equals to 0. So our value for a, it is 0. So here where there is a, it is 0. So now you can say that our value of a, it is equals to 0. We can prove that when a it is equals to 0, we can say that from this equation which we have here, you can substitute a into this equation which we have here, in which you're going to have y minus y1, it is 0, which is equals to minus 1 over 3, then plus here you're going to have let's open bracket here, x minus x1 we have 3. Okay, let's create a space here, because we have already found the value of a. Now I'm just trying to prove, to show you that a it is equals to 0. Okay, here we have 3, in which here you're going to have y equals to minus 1 over 3x plus 3. this is the equation which is there, which is correct for you to find the value of a is 0, and we have the intercept of 3, which is correct. So now, since we have found the value of a is 0, so now let's move on to another question, which is question 22b. Okay. I hope you are following what I'm doing here. So let's find here we have to find as the 22b, my number 1, we have to find the equation. Equation of the curve. How can you find the equation of the curve from this point which you have been given? We have -5, 0 and -1, 0. We have -5 and -1, in which you can say x it is equals to -5 or x it is equals to -1. So we have to take back these values where they come from, or ask to generate the equation which they are asking for. When -5 across the cosine to be ax plus 5, ax plus 5 in brackets, then when -1 across the cosine to be x plus 1, which should be equals to 0. So now let's try to expand. X times x, which is x squared, then plus x times 1, which is x, then plus 5 times x, we're going to have 5x, 5 times 1, which is plus 5, which should be equals to 0. So x squared plus x plus 5x, you're going to have 6x, and plus 5, it should be equals to 0, but the standard equation to be y equals to x squared plus 6x plus 5. So this is the equation which they were asking for. Okay. This is the equation which they were asking for. Now let's try to find the turning point of this equation which we have here. The equation it has been given as y equals to x squared plus 6x plus 5. Okay. So now let's find the turning point. The turning point, it is this one for x and for y. So the turning point of these values, it will be here we have a, and here we have b, c. Okay, in which for finding the turning point of x, it is x equals to minus b over 2a. If you want, you can just differentiate this one. You're going to have the same answer as the x turning point. X equals, where is a we have, where is b we have 6, we have minus, then over 2, where is a we have 1 here. Okay, in which x it will be equals to minus 2 times 1, which is 2 into 6, you're going to have minus 3. So this is the turning point for x. If you want, you can just do like y prime, you differentiate this equation, which is x squared. When you differentiate, you're going to have 2x plus 6x, 6, just 6 here, okay, in which when you say y to be equals to 0, you're going to have 2x plus 6, which is equals to 0. Then 2x equals to 1, 6 across the sign to be minus 6. Then you divide throughout by 2, and x to be equals to minus 3. So you can use either way, this way to find it. You're going to find negative 3. If you differentiate this equation, you're going to find negative 3. So for finding the turning point of y, we can say y equals to, well, is x substitute with negative 3, in which you're going to have minus 3 squared plus 6 times minus 3, okay, then plus 5, in which y to be equals to 3 squared, it is 9, then plus 6 times 3, which is 18. So here you're going to have minus, because of this negative here, negative times positive, which is negative 18, then plus 5, okay. Then now 9 minus 18, you're going to have minus 9 plus 5, in which y to be equals to minus 4. So this is the turning point for y. For part 22, we are done. So now let's try to move on to another question. Which is the speed time graph. Okay, this is the speed time graph. It was like this. It was like this. Like this. Because of space, that's why I'm doing part by part. So this is another question for speed time graph. Here it goes like this one. Okay. In which time in seconds, then velocity, which is speed in meters per second, and here we have 35, here we have 20, and here we have 0, here 10, here 25, here 40. Number 1, we have to find a retardation. Retardation in first 10 seconds, then B speed of the particle when t is equals to 31. Okay, then C average speed of the particle for the whole let's say journey. The whole journey. Okay. So now this is question 23, the last question for 2024 paper 1. So we are told to calculate the retardation in the first 10 seconds. The retardation in the first 10, this is the retardation we are talking about. Okay, retardation is equals to final velocity minus initial velocity over time, in which it will be equals to final velocity. Final velocity is the last velocity, which is 35, then minus initial when this car started, it is 20, and over time it is in 10 seconds. Okay, in which it will be equals to 35 minus 20, it is 15 over 10. Then now, which number can go 15 into 15 and 10? It is 5 into 15, which is 3 over 2 meters per second squared, because we have to find the retardation, which is the same as the deceleration. Retardation. Okay. So now let's move to another question for one retardation. We are done. So let's find the average speed of the particle when t is equals to 31. Over here. Okay. When time it is equals to 31. If you can see from this time graph, you don't have 31. So 31 can lie in between 25 and 40. So you can draw here. This is what. Okay. And for solving this, you can use similarity, congruent, and similar this one here. Okay. Here we have y, and here we have 20. This is 20. Here height 20. Then down you have 0.5. Then 31. Then 40. Okay. In which, when you use similarity and congruence, you're going to split this shape into two parts, in which we have this one. You have this one as this whole, the big one, it is when you subtract 25 minus 40, you have 40 minus 25, you're going to have 15, here 20. Okay, and the smallest one from here to here, you're going to have like this. Don't mind my drawing. Okay, like this. Here we have y 81. When you subtract 40 minus 81, you are going to have 9 here, and here 40. So we are going to use this similarity here. 20, it is equals to 15, okay? And the y it is equals to this 9 here, okay? Which is 9 here. Then you cross multiply, in which you are going to have 15y equals to 20 times 9, which is 180. then divide throughout by 15 in which y to be equals to 15 into 18, you're going to have 1, remainder 3, 15 into 30, it is 2, so it will be 12 meters per second, because we are only asking to find the speed, which is the velocity. The velocity, it is measured in meters per second. Okay, and that first one, retardation, if I forgot, it is measured in retardation. We have 3 over 2 as meters per second squared. Okay, for the first one here, A, and for B, this one here, the speed. Okay, so now let's find the average speed of the particle for the whole journey. Okay, we are going to find the average speed for the whole journey. So the average speed for whole journey, we can draw here. Let me just draw here as a temporary one. I'm just doing this one for us to find these answers. This is just a sketch. Okay. Here we have 35, 20, 0, 10, 25, 40 as the time, which is seconds, and the meters per second. Okay. So now let's find the average speed for the whole journey. We all know that speed, it is equals to distance over time. Okay. So we're going to find the distance throughout this. This is the trapezium here. Okay. This is the trapezium. Trapezium, it is like this one. Here we have 25. Then height from 0 to 20, it is 20. Then we have 40 here. Okay, so now let's find the area of this trapezium. We all know that area of trapezium, it is equals to half A plus B, then a height, in which A, it will be equals to half A is the distance from this point to this point. This is A. Then B from this point to this point here. Okay, in which it will be 25 as A, then plus A, 40, close bracket, then height we have 20. Okay, then 2 here, 1, 2 here, 10. Then 25 plus 40, you're going to have 65. 65 times 10, you're going to have 60. 650. Okay, this is just the distance for this. So let's find the distance for this remaining part now. Okay, this is the meter. This is the average speed, meter as meter per second, because we are finding the speed. Okay. So now let's find the remaining one. This is the remaining one here. Okay, and if you can see, this is a triangle. It is like this. Here we have 35. Here we have 20, and this distance, it is 10 here as a time. Okay, so 35 minus 25 minus 20, you are going to have 15. Okay, we all know that area of the triangle is equals to half the stand height, in which area to be equals to half our base. It is this base here, it is 10, then height is 15. Okay, then 10 times 15, you're going to have half, then open bracket 150. Don't divide here before you multiply. Okay, you must multiply first, that's when you can divide. Then 2 into 150, you're going to have 75 meter squared. Okay, because this is an area, meter squared. So now let's find, because we're only focusing to find the average speed for the whole journey. Okay, in which we have 650 plus 75, in which we are going to have 7:25. So now speed equals distance over time, in which it will be equals to 7:25 divided by time, which is 40, in which speed it will be equals to 18.25 let's check where. If you want, you can just leave it like the way it is, but let's it's 18 point 18 point. So the answer will remain as a fraction here. Okay, let's just wait as we'll be finding $7.5 here. 7.5 divided by 40 is equals to 18.125 meters per second. So this is the average speed for the whole journey. This is for C. Okay, this is where we end. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you can see you next time. Bye bye.